Look carefully at this image. The stars are stretched into long white lines, but one object isn't. Right there in the center, sharp, compact, glowing. That's 3I Atlas. This frame was captured on February 11, 2026 by Graziano Ventre at Postazione Astronomica, Sormano 2 in Italy, MPC station L06. The telescope tracked the object itself, not the sky. That's why the background stars appear streaked. And that detail matters, because it confirms two things. First, 3I Atlas is still moving rapidly against the background field. Second, it's still active. You can see a defined coma surrounding the nucleus, not a point source, not inert. This object is still releasing material into space. Now here's where things get interesting. Some people expected activity to decline more rapidly by this stage. Others argue that what we're seeing is completely consistent with cometary behavior. So which is it? Is 3I Atlas behaving exactly as expected, or is this new image telling us something different? Let's break it down carefully. Now let's focus on what this frame actually shows. This observation is a stack of 25 exposures, each 120 seconds long. That's 50 minutes of collected light. This isn't a quick snapshot, it's a deliberate tracked capture. Look at the stars first. They're stretched into lines. That immediately tells us the telescope was tracking 3I Atlas, not the sky. The mount followed the object's motion across the star field, keeping it sharp while the background trails. That confirms measurable movement relative to the stars. In 2-minute exposures, the motion is strong enough to elongate the entire field. Now move to the center. The nucleus is condensed, but it's not stellar. If this were an inactive asteroid, it would appear as a tight point source matching nearby stars. Instead, there's a diffuse glow surrounding it. That glow is the coma. A coma forms when volatile material heats up and sublimates, releasing gas and dust. Sunlight reflects off that dust, creating the visible envelope. And this coma is clearly present. It's compact, yes, but it's not symmetrical like a static blur. There's a subtle extension in one direction, suggesting continued material flow. That's active outgassing. Now, here's where opinions start to diverge. Some observers say this level of activity is exactly what you'd expect at this distance from the sun. Nothing unusual, just a comet behaving like a comet. Others argue that for an interstellar object, sustained activity is especially interesting. If it formed around another star, its volatile composition could differ from typical solar system comets. From this image alone, we cannot claim anything exotic. But we can say this clearly. 3I Atlas is still active. It is still releasing material. And its motion through the star field is unmistakable. That's not interpretation. That's what the data in this frame shows. So here's where things stand. We have a tracked observation showing clear motion against the background stars. We have a defined coma. We have measurable ongoing activity. Nothing speculative, nothing dramatic, just evidence. 3I Atlas is still active, and that matters, because every new frame adds to the timeline. Every observation helps us understand whether this object behaves like a typical comet or whether subtle differences begin to emerge over time. Right now, the safest conclusion is this. It's behaving like a comet, but it's still an interstellar one, and that alone makes it worth watching carefully. The real question isn't whether it's active. The real question is how that activity evolves from here. Does it decline steadily? Does it fluctuate? Does anything unexpected appear as it moves farther from the sun? We'll only know if we keep tracking it. If you want continued updates and real analysis, not hype, not speculation, subscribe and stay with this story as it unfolds, because 3I Atlas isn't done yet.